Okay. Localized electron bonding model. So this is for covalent bonds. This assumes a molecule is made of atoms bonded together by sharing electrons. So a lone pair is a pair of electrons that's just on one atom, and a bonding pair is between atoms. Lewis structure. Remember we did these. For just single elements. Valence electrons as dots. And count the tall columns. So when we bond them together, we use the octet rule. Everybody wants 8, except for hydrogen. Hydrogen's the baby, only wants 2. So we can do Lewis structures. Right there we just did them for elements. We can do them for compounds. We can do them for ions. If you have a negative charge, it means you have that many extra electrons. If you have a positive charge, it means you have that many fewer electrons. So here's our procedure. Count electrons. So here's our compound. H brings 1 electron. Get another H, it brings another electron. Oxygen brings 6 electrons, so we have 8 electrons to work with. Now, what's the central atom? Central atom is going to be the one with the most single electrons, because that one can form the most bonds. So oxygen is going to be in the middle. Hydrogens are going to be on the sides. So now, bond atoms to central atom with single bonds. Okay, so a bond is 2 electrons. But we use a dash. So we've got to subtract this. So we've got 4 electrons left. So we have to distribute those to satisfy octet rule. So oxygen, if we give it 1 lone pair there, that's 2. So we've got 2 more. Another lone pair there. Everybody's good. If we look at hydrogen, hydrogen's got the 2 that it needs. Look at this hydrogen. It's got the 2 that it needs. Look at oxygen. 2, 4, 6, 8. It's got the 8 that it needs. And we end up with a lovely Venn diagram. You won't ever draw those circles. Now, carbon dioxide. Let's do our electron count. Carbon brings 4, so we're only counting valence electrons. Oxygen brings not 8, because we only count valence electrons. Oxygen brings 6. Another oxygen brings another 6. We've got 16. Carbon in the middle. Oxygen's on the side. Bond to central atom with single bonds. So we've used 4. We have 12 electrons left. So distribute remaining electrons as lone pairs to satisfy octet rule. So 2, 4, 6, 8, 10, 12. Uh-oh, I've run out of electrons. And this oxygen over here doesn't have the 8 that it needs. So, not going to be done at this after step 4. Some atoms might need double bonds. So, oops, I didn't mean to get rid of my carbon. I'm just trying to get rid of these lone pairs. Guess I'm starting over from scratch. I had my carbon in the middle, my oxygens, and used those 4. So let's put a double bond there. So that's another 2. So now I have 10 left. So now this oxygen would need 4. Carbon would now need 1. So I've got 10 electrons. 2, 4, 6, 8, 10. Well, that oxygen still doesn't have all it needs. So let's get rid of that lone pair. Get rid of these lone pairs over here. And try get the pen to switch. Oh, for goodness sakes. There we go. And now in my trial and error, kind of lost track of my electrons, but I've got 2, 4, 6, 8, 10, 12, 14, 16. Used all of my electrons. And satisfied the octet rule.